Hey, let's have a look at how we can use partial HTTP mocks to solve some typical QA environment issues. So some of those typical environments you see on day-to-day basis at certain organizations are QA environment unavailable. For example, once a week the environment goes down for several hours. The environment is unstable. For example, a few times a week the environment returns unexpected errors due to core banking system failures. The environment conflicts between teams. So teams use each other's logins in the test environment and modify each other's test data, stepping on each other's toes. There's typical test data issues. For example, test data setup in these shared environments is time consuming. For example, test data setup requires days or weeks of work by a specialized team once a month. You're burning through test data. For example, multiple store item purchases in the test environment take down the stock quantity to zero. So you go with purchase 110, purchase 19, purchase 18, and there's no more purchases that can be tested. You've burned through the test data. Or you've got limited test scenarios. So again, a test data issue where, for example, selected test scenarios are missing in the testing environment. And the long-term solution to this problem is to, first of all, stabilize your shared environments, and second of all, rely less on shared environments. And by that we mean implement a testing pyramid or a testing honeycomb where you use tools like mocking in certain types of tests. There's many good articles written about this. I recommend having a look at Mountain Fowler's practical testing pyramid, Spotify testing honeycomb, and the article by us where we've got 3 parts where we dive into 12 testing techniques for microservices, okay? However, there's a quick fix to alleviate those critical issues. So let's say we're working in this QA environment where we're testing this finance application and we've got this core banking application that's returning all these errors. So we got data setup issues, we've got environment availability issues, we've got environment scheduling issues, etc., the issues that we've discussed. How can we solve this problem with a quick fix? What we can do is use partial pass-through or proxy HTTP mocks. So the way this works is we're going to have Traffic Parrot as a HTTP pass-through proxy mock, and based on the test data that is configured with, for some test data it will return mocked responses, and for some test data it will return the real responses. So that way you're able to work with the real data, with the real core banking system if you want to, but you can also, if it goes down or if it's intermittently unavailable or returning errors or the test data setup issues, and you need additional test data, you can set that up in Traffic Parrot in your mocked responses. Okay, why or how does that solve those problems? Well, first of all, the environment's unavailable, the partial mocks are always available. The environments are stable, the partial mocks are stable, they are under your control. The environment conflicts between teams. How is that problem solved? Well, partial mocks allows for separation of teams by using different sets of test data. You can segment the test data. What about the test data issues like setting up test data? Well, partial mocks test data setup is automated for you, so you don't have to rely on external teams, and it's within your control as well. So you don't have the issue with burning through test data. Partial mocks test data setup is automated and refreshes are automated as well. So you can do it automatically or with a click of a button, just refresh the test data and you're not burning through the test data anymore. Or you're burning through the test data but it's not blocking you because you can do the refresh automatically. And similar with limited test scenarios, partial mocks have more scenarios set up, including error and hypothetical scenarios. So let's have a look at how you could create those partial pass-through proxy mocks with Traffic Parrot. Okay, so first of all, let me show you an application I've got here. This is our finance application. It shows a few stock quotes. You can see it shows the Apple stock quote. The prices right now for the stock $248, Google, Amazon, and there are different prices. You see the prices change. And we've got this new company called Nanomed, and it's not listed yet on the stock exchange, and the price is for some reason the same as Amazon. This looks like a bug, right? With our test environment. So let's have a look at the logs of that application on the console. And we can see here that when we're executing this request to get the stock quote for Symbol Nano, which is this new company, the core system, the backend systems return an error. and this application doesn't know what to do with this, so it just leaves the previous price. So this is obviously a bug that we need to fix. However, how do we fix this if we don't have the access to setting up Nanomed's test data in the backend system? Well, what we can do is use Traffic Parrot, put it between this application and the backend systems, like you saw in the diagram before, and make it a partial mock. So Apple, Google, and Amazon stock quotes will be coming back from the real systems. However, the Nanomed nano stock quote will be coming back from a CSV file served up by Traffic Parrot. Okay, so in order to do that, I'm gonna spin up Traffic Parrot. It started already here. I can go to HTTP and add edit, and I've got those mocks prepared here already. So I know the requests sent by the application to the backend system always go to this URL /stock quote. So I'm going to use that. And now we need a request and response matcher. So the way we're going to do this is we're going to have two mappings in Traffic Parrot. The first one's going to match just the mocks, and then the second one is going to match everything else and forward to the real system. So let's create the first one. So the first one will say that whenever you see a request to /stock quote, and we'll create a little script here, and this script will say, if we look at it, so if you see a request to /stock quote, and if you look at the CSV file called stocks CSV and extract the symbol from it, so select symbol from stocks where symbol equals the one in the request, so request query symbol. So if you see in our CSV file that we'll create in a minute a quote for a stock, just return it. So this is going to be the mocked response. Okay, and how do we return that mocked response? Just like this. This is we're going to be returning a HTTP status code 200. The structure, the JSON structure, a status, name, symbol, the name and the symbol we take from the request, and the last price will be taken again from the stock CSV file. We're just looking up the price for the stock quote, the symbol that came in the request. Okay, we'll just save that. So what we've got right now is a mock that loads up data from a CSV file. We don't have that CSV file. Okay, so let's go ahead and create this CSV file in Traffic Parrot. Okay, so I'm in the main Traffic Parrot directory. There's a data directory here, and I've created this stocks.csv file. It's a very simple file. If you have a look at it, it's a CSV file, and it's got a symbol and price columns. We've got a nano symbol here, and the price should be this 987.22. Okay, so we can close this. So right now what we've got is a mock that looks up the data in the database and serves it to the user. We'll set the priority of this mock to 1, which means this is the mocked responses are always going to be returned unless there's no mocked responses. Okay, and then we'll go to the real system. How do we go to the real system? We need the real system URL, and we'll create a new mock for that. Sorry, a new mapping in Traffic Parrot for that. So again, if the request URL is /stock quote and no other requests have matched, so we'll set the request priority to 5. So number 1, the mocked one, will be matched first, and this number 5 will be matched later, only if there's no mocked responses. What we'll do is proxy everything to the real API. Save that. And this is it really. So what we've got right now is Traffic Parrot with two mappings. The first mapping is this one, and what it does is looks at the stocks CSV file, and if our stock is there, it returns its price. Okay, and if this does not match, if the row is not in that CSV file, this will match, which means everything will be proxied to the real server. So what we've got in Traffic Parrot right now is a partial mock with pass-through or proxy, however you want to call it, set up to the real API. So right now what's missing is our finance application is still connected to the real system of Traffic Parrot, so we need to connect our finance application to Traffic Parrot. And the way we do that is we open up the properties file of this finance application, and you can see it's connected to real API, and I'll connect it right now to Traffic Parrot, which is running locally And that's it. So if I refresh this page, Apple stocks, Google stocks, and Amazon stocks are coming back from the real system, and Nanomed, you can see the price is good now. So 987.22 is coming back from that CSV file from Traffic Parrot, right? So all of the traffic is actually forwarded from this application to Traffic Parrot, like in the diagram we saw earlier. And some of the requests are being served from the mock, and some of the requests are being forwarded to the real services. So we got a partial mock that solves the problems that we've discussed with QA environments like unavailability, test data setup issues. Okay, so if you'd like to create something like this for your company, feel free to reach out to us. We'll be happy to help you. And yeah, looking forward to hearing from you. Bye-bye.